Okay, good afternoon. In this video we're going to be factoring special patterns, and by special patterns I mean the three patterns given a couple of videos ago. One of them was called difference of squares. And the other two were both called perfect square trinomials. The first one was the product of a sum of two terms, a square of a sum of two terms. And the other one was the square of a difference of two terms. Oops. Creating a negative middle term. And this is also called perfect square trinomial. So these are the three special patterns that we're going to deal with when factoring for now. There are other patterns that we'll see in the future. So, as you know, going from left to right, this is multiplying. This is multiplying, this is multiplying. In factoring, since factoring is the opposite operation of multiplication, we will go from right to left. So we're going to go in this direction. Which means that you need to first, if given one of these patterns, you have to first be able to recognize which one it is, or if it's neither of them. And then, once you recognize which pattern it is, you need to be able to identify what A and B are so that you can place them in the factored form of each pattern. So I'm going to start with an example of difference of squares. X squared minus 36. So first you need to identify which pattern is it. Well, it's obviously not any of the two perfect square trinomials because it only has two terms. Does it fit a squared minus b squared, the difference of squares? Look at it term by term. Yes, x squared is a perfect square, so it corresponds to a squared. 36 is also a perfect square, so that corresponds to b squared. So now, yes, you know that this is a difference of squares, and it can be factored like this. So now you have to identify what a and b are. If x squared corresponds to a squared, then that means that a equals x. If 36 corresponds to b squared, then that means b must be 6. So now we can place x and 6 in this pattern. A plus b times a minus b. X plus 6, x minus 6. Now here's an example where the binomial does not fit the pattern of difference of squares. Yes, x squared is a perfect square, so it does correspond to a squared, but 10 is not a perfect square, so it does not fit b squared. So this cannot be factored into rational factors. So we would just leave this the way it is if we were asked to factor it. Cannot be factored. It is prime. Just like numbers can be prime, polynomials can also be prime. Okay, now for an example of the first pattern of the first type of perfect square trinomial, we first check, is this a perfect square? Yes. Then we check the third term. Is this a perfect square? Yes. Okay, if the first one corresponds to a squared, that means a is x. And looking at the third term, b is 7. Now, in order for this to be a perfect square trinomial, the middle term has to fit certain requirements. The middle term must be of the form 2 times a times b. So it must be in this case, 2 times x times 7, or 2 times 7 times x. It must be 14x, which it is. So this corresponds to 2ab. Therefore, the entire trinomial fits the perfect square trinomial form, and we may factor it according to this pattern. X plus 7 times x plus 7. Or if you wish, you can write it as x plus 7 squared. Okay, now for the other perfect square trinomial. Okay, I have a trinomial, so it could be perfect square trinomial. I have a perfect square here and here. So yes, it still could be a perfect square trinomial. Now I check the middle term. Is the middle term 2ab? Is the middle term 2 times x times 3? It is. So it checks out. That means I can factor it. X minus 3, x minus 3, or x minus 3 squared. Okay, the last thing I want to do is combine one of these patterns with GCF factoring. GCF factoring. So when you have two different types of factoring involved in a polynomial, it's wiser to first do the GCF factoring. So if you see a trinomial or a binomial, first take out the GCF. So first priority, always take out the GCF. Then the leftover, the part that's in the parentheses after you take out the GCF, the leftover might be itself a special pattern, one of these three patterns. If it is, then you have to factor the leftover like this, or if it's a difference of squares, like this. So it's a two-step factoring process. Take out GCF, then factor the leftover, if it's a pattern. If it's not a pattern, you can just leave it and you're done. Okay, so I'm going to give you this. 2x squared minus 50. It's a binomial, so it might be a difference of squares after I take out the GCF. So first step, I take out the GCF if there is one. And looking at both terms, 2 and 50 are even, so I can take out a 2. That's my GCF. Now I write the leftover. X squared minus 25, which is a difference of squares. So I can factor that. Remember, the 2 is still there, followed by x plus 5, x minus 5, the difference of squares factored. Now I'm completely done. It's a two-step factoring process. GCF for this step, and then difference of squares for that step. What I've done basically is I've taken 2x squared minus 50, and I've taken a 2 out, leaving x squared minus 25, and then I factored x squared minus 25, x plus 5, x minus 5. So you see this factor tree represents what I've done to 2x squared minus 50. I factored it down to as far as I can get. And I have three factors, 2, x plus 5, and x minus 5. Okay, now for an example of two-step factoring with a trinomial. Okay, so first I look for the GCF. My GCF here is x. Then I write the leftover. Now I check the leftover to see if it can be factored. Is it one of my patterns? And it is. This is a perfect square trinomial. Square root of x squared is x, square root of 16 is 4, and the middle term is 2 times 4 times x. So this trinomial becomes x plus 4, x plus 4. So this trinomial factors into 3 factors, x and then a couple of x plus 4s. One more example. Again, the GCF here is x. But if you look at the leftover, this is a perfect square, but this is not. Therefore, this is not a perfect square trinomial, and there's no other way to factor this either. There are other ways of factoring, but even if you examine the other ways that I haven't taught you yet, this is prime. So this is as far as you can go when factoring this trinomial. All you can do is take out a GCF, and that happens sometimes. You can take out a GCF, but you can do nothing else. Okay? So that's factoring special patterns. See you next time.